Good afternoon, class. Today we'll be learning to use the least squared method of adjustment and error propagation to adjust values. We'll be jumping straight into a problem question, where we have to use both methods. I will now present that to you. Sure. The first question asks to effectively adjust measurements given in the model below using two least squares methods. Figure Q1 depicts angles measured above a survey station. The observed value is 1, which is 65 degrees, A2, which is 65 degrees and 30 seconds, A3, which is 230 degrees and 20 seconds, and angle A4, which is 130 degrees and 25 seconds. It says all measurements are uncorrelated and have the same precision. Adjust the measured angles using least squared adjustments by the method of adjustment of indirect observations and adjustment of observation only. Here we can see that the shape resembles a circle with A1, A2, and A3 adding up to 360, and A4 and with A3 also adding up to 360, along with another relationship which is A1 plus A2 will be equivalent to A4. We shall now jump into my solution. Here we have rewritten the question with the values of here. We also added a few more criteria. We have number of values, which is n, which is equal to 4. The number of observed values required to get your value, which would be 360, and R, which is the number of redundant observations, which is n minus NO. The first observed value we have is the 65 degrees. So we have A plus the residual, which is V1, is equal to A hat 1, which would be reduced observation of A. We rearrange the equation to find the residual of V1, which will be A hat minus 65 degrees. We do that for the second question. For the third question, it's slightly different. In order to find the residual of A3, which is 230 degrees, we will use A1 and A2 to solve the equation. So it'll be 360 minus A1, sorry, A hat 1 plus A hat 2 is equal to the residual of B3, which is equal to 129, 59, 40 minus A hat 1 minus A hat 2. And similarly, we will also use A1 and A2 to find the residual of V4. So V4 will now be A hat 1 plus A hat 2 minus 130 degrees and 25 seconds. We do this to use the same observations, the minimum observations, to find the residuals for all of the values. We now have phi, which is equal to 0. So phi equal to 0 is equal to V1 squared plus V2 squared plus V3 squared plus V4 squared. We now sub all of the equations that we created into the formula. So that leaves us with A hat 1 minus 65 degrees squared plus A hat 2 minus 65 degrees minus 65 degrees second squared plus 129 degrees, 59 minutes and 40 seconds minus A hat 1 minus A hat 2 all squared plus A1 plus A2 minus 130 degrees, 25 seconds all squared. So using partial differentiation, you're looking to find the minimum value of the residual. So we partially differentiate phi in respect to A1. We first do this by bringing the 2 down and multiplying by the residual, which would be -1, which would be +1, as A1 is positive. We continue along with the second value, we bring down the 2 again, but this time A1 is negative, so we multiply by the residual. This is -1. And lastly, for the third equation in the problem, we bring down the 2 and the residual is positive in this case, so multiply by +1 this time. Expanding the brackets, we now have 2a1 minus 130 degrees minus 254 degrees, 59 seconds and 59 minutes and 20 seconds plus 2a1 plus 2a2 plus 2a hat 2 plus 2a hat 2 minus 260 degrees, 0 minutes and 50 seconds. I made an error here. This is supposed to have a hat on here, but let's continue. Now we have the value 6a hat 1 plus 4a hat 2 is equal to 650 degrees, 0 minutes and 10 seconds. Partially differentiating with respect to a2, we use the same procedure. We bring down and multiply by the residual of the value. So you have 2, the residual of a2 is 1. We have 2 again here, the residual of a2 this time is -1, so you have -2. Then you have 2 again when the residual of a2 is positive. We expand the brackets once more and give us 2a2 minus 130 degrees, 1 minute, 0 seconds, minus 259 degrees, 59 minutes and 20 seconds, plus 2a hat plus 2a hat 1 plus 2a hat 2 plus 2a hat 1 plus 2a hat 2 minus 260 degrees. We rearrange, we add all like terms. It should give us 6a2 plus 4a1, and we separate the unknown with the knowns. So we have 6a2 plus 4a1, which is equal to 650 degrees, 1 minute and 10 seconds. This now gives us two equations with two unknowns each. So we put both, so now we will solve both equations simultaneously to find our two unknowns. So we have 6a1 plus 4a2 is equal to 650, as 650 degrees, 0 minutes, 10 seconds. And we also have 6a2 plus 4a3 is equal to 650 degrees, 1 minute and 10 seconds. So we are solving here to eliminate a2. So we will multiply equation 1 by 2 and equation 2 by 3. This gives us 12a1 plus 8a2. Sorry, we solve to eliminate a1. And 18a2 plus 12a1. These two will cancel. And then we have 8a squared, 8a2 minus 18a2 and 1300 minutes, 0 minutes, 20 seconds, and 1950 degrees, 3 minutes and 30 seconds. Moving along, so we get from this, we get minus 10 a2 is equal to minus 650 degrees, 3 minutes and 10 seconds. We now divide both sides by -10. So you have a hat 2 is equal to 650 degrees, 3 minutes and 10 seconds on 10, which is equal to 65 degrees, 0 minutes and 19 seconds. So we sub this formula into equation 1, which gives us 6a1 plus 4 by 65 degrees, 0 minutes and 19 seconds, which gives us 650 degrees, which is equal to 650 degrees, 0 minutes and 10 seconds. Multiplying out, and so we multiply 4 by 650, 65 degrees, 0 minutes, 19 seconds, and we subtract that from both sides, which will give us 6a1 is equal to 389 degrees, 58 seconds and 54 minutes. 58 minutes and 54 seconds. So a1 is equal to 64 degrees, 59 minutes and 49 seconds. So your values would be 64 degrees, 59 minutes, 49 seconds for a hat 1, 65 degrees, 0 minutes and 19 seconds for a hat 2. Using the equations that we formulated, we would plugged in the values of a hat 1 and a hat 2 and to find the reduced observations of a hat 3 and a hat 4, which would be the 360 minus a hat 1 plus a hat 2 and a hat 1 plus a hat 2 minus the 130 degrees and 25 seconds. Sorry, no. A hat 1 plus a hat 2, which would be equal to the reduced observation of the value. So we have 360 degrees minus 64 degrees, 59 minutes and 49 seconds, plus 65 degrees, 0 minutes and 19 seconds, which will give you a reduced observation of 229 degrees, 59 minutes and 52 seconds. Following on with a hat 4, which will give you 64 degrees, 59 minutes and 49 seconds, plus 65 degrees, 0 minutes and 19 seconds, equal to 130 degrees, 0 minutes and 8 seconds. So now we have found the reduced observations of each value that is given. I would like to pause here to get my chart. Okay, continuing on, we will now solve the question using the direct method. As stated before, we have our 4 values with our N, our NO, and our R. This time, we will use, as previously stated at the beginning, A1 plus A2 plus A3 is equal to 360. A3 plus A4 is also equal to 360. So we use those two relationships to form an equation. So we have the angle A1 plus the residual V1 plus the angle A2 plus the residual V2 plus the angle A3 plus the residual of V3 is equal to 360. And the angle of A3 plus the residual of V3 plus the angle of A4 plus the residual of V4 is equal to 360. We again rearrange the equation to solve for the residual. So now we have V1 plus V2 plus V3 is equal to 360 minus A1 plus A2 plus A3. This gives us 360 minus 65 degrees plus 65 degrees 30 plus 230 degrees 20 seconds, which leaves us with a value of 50 minus 50 seconds minus V2 minus V3, making V1 the subject. And then we also have equation 2, V3 plus V4 is equal to 360, open brackets, A3 plus A4 minus, open brackets, A3 plus A4, which is equal to 360 degrees minus 230 degrees 20 seconds plus 130 degrees 25 seconds. Solving for making V4 your subject, you have minus 45 seconds minus V3. Same solution again, we have phi is equal to V1 squared plus V2 squared plus V3 squared plus V4 squared. Now subbing the two equations that we formed into phi, we have 50 degrees is equal to V2 minus V squared plus V2 squared plus V3 squared plus minus 45 degrees minus V3 squared minus V3 all squared. We now will partially differentiate to find the residual, partially differentiate phi in respect to V2 and V3 as our 3 unknowns. There are 2 unknowns. So we bring the 2 down, multiply by the reciprocal of V2, which is -1, and we differentiate V2 squared as 2V2, which gives us 1 minute and 40 seconds plus 2V2 plus 2V3 plus 2V2. Rearranging the equation, separating the unknowns with the knowns, we have 4V2 plus 2V3, which is equal to -1 minute and 40 seconds. Partially differentiate the equation again with respect to V3. We bring down the 2, multiplied by the residual of V3, which is -1. Differentiate V3 squared, which gives us 2V3, and differentiate the third equation, which is minus 45 seconds minus V3 by the reciprocal of V3, which is -1. Expanding the brackets, we have 1 minute and 40 seconds plus 2V2 plus 3 plus 2v3 plus 1 minute and 30 seconds plus 2v3. This gives us 6v3 plus 2v2 is equal to a negative of 3 minutes 10 seconds. Solving the equation simultaneously again. Here we multiply equation 2 by 2 to get rid of v. So you end up with equations 4v2 plus 2v3 is equal to minus 1 minute and 40 seconds, and 4v2 plus 12v3 is equal to minus 6 minutes and 20 seconds. Getting rid of the v2s, minusing equation 1 from equation 2 gives us 0v2 plus 10 minus 10v3 is equal to 4 minutes and 40 seconds. Dividing both sides by 10, by negative 10, we get v3 is equal to minus 28 seconds. Solving, plugging v3 equals 20 minus 28 seconds into the equation 1, we have 4v2 plus 2 times minus 28 seconds is equal to negative 1 minute and 40 seconds. So we have 4v2 plus minus 56 seconds is equal to minus 1 degree, minus 1 minute, 40 seconds. 4v2 is equal to minus 44 seconds as we minus the 50, add 56 to both sides, 56 seconds to both sides. Dividing minus 44 by 2 is equal to minus 11. V1 is also equal, or to solve for V1 and V4, we use the equations that we formulated at the beginning. Solving for V1 and V4 is minus 50 seconds minus V2 minus V3, and minus 45 seconds minus v3. Having now found v2 and v3, we can now plug the values in to find the residual of v1 and the residual of v1 and the residual v4. This is minus 50 seconds minus 11 seconds minus negative 11 seconds minus negative 28 seconds. This will now give you minus 11 seconds, and v4 will be minus 45 seconds minus 28 seconds, which gives you minus 17 seconds. To check, we can plug these residuals into the first two equations that we formulated, which would be these equations, a1 plus v a1, the angle plus residual of 1, the angle plus residual of 2, the angle plus the residual of 3, which equates us to 360. The angle of 3 plus residual of 3 plus the angle of 4 plus the residual of 4, which gives us 360 again. And by inputting these residuals and angles in, we can see that we have solved the question successfully as both of the equations equal to 360. Moving on to question 2 of the problem. I will now bring it up again. I hope you understand the last question. Number 3, share. Okay, moving on to question 2, where we're using error propagation to solve the area of a triangular parcel of land that is to be computed from independent measurements of side B, angles alpha and beta. The function area is equal to b squared sine alpha plus beta, all on 2 sine beta. Side B, and angles alpha and beta were measured and found to be 100 meters, 55 degrees, and 25 degrees, respectively. The errors are 0.01 meters, 15 seconds, and minus 25 seconds. Evaluate the area by determining the difference between the area computed from the measured values of measured values of B, alpha, and beta, and the area computed from the corresponding true values. Applying the partial derivatives of dy dx of dy. Looking back to our problem, solution to the problem. I would now switch tabs once more. This resolution share. Okay, moving along. You can see we brought question 2. We have the area formula along with the values of the values of B, which is 100 meters, at A 55 degrees, and B 25 degrees. We also have the errors 0.0 meters of B, 15 seconds of alpha, and minus 25 seconds of beta. Plugging the equation in to find the area of the observed values, we have 100 squared sine 55 degrees, sine 55 degrees plus 25 degrees, all on 2 sine 25 degrees. Solving the top and the bottom separately, we have 8,000. The top gives a value of 8,067.073, and the bottom value gives you 0.845. Solving the equation, we get 9,546.832 as our observed value area. Using the corrected value area now, we correct the value based on the error. So we have 100. So it'll be the observed value minus the error. So we have 100 minus 0.01, which gives us 99.99 squared, sine of 54. This would be 55 degrees minus 15 seconds. So you get 54 degrees, 59 seconds, 59 minutes, 45 seconds. Sine of A of alpha again, and this time sine of beta, which is 25 degrees plus, well, minus the negative of 25 seconds gives us 25 degrees, 0 minutes, and 25 seconds, all on 2 sine beta, which is 25 degrees, 0 minutes, and 25 seconds. Solving the top, we get 8,065.118, and the bottom, again, we get 0.845. This gives us a value of 9,544.581. Here we find the difference, which is 9,546.832 minus 9,544.581, which gives us a difference. Here we have forgot to solve for one equation, which is the difference as the answer it had asked for. Let me show you the question once more. It asks for the area computed from the corresponding true values. No, I just read the question wrong the second time. Sorry about that, class. Moving on. Back to the solution. Sure. This gives us the difference of 2.314 meters squared. Sorry for forgetting my units. Question 2 asks you to solve the residual using partial differentiation. So we have the partial differentiation of the area, well, in respect to B by the error in B plus the partial derivative of the area with respect to alpha by the partial derivative by the error in alpha plus the partial derivative of the area in respect to beta plus by the error in beta. You can scroll back to the top to show the equation. You have area is equal to B squared plus sine A, sine alpha, sine alpha plus beta on 2 sine beta. This gives a solution of differentiating with respect to B. We bring down the squared from the B and minus 1, which gives us 2B, and the rest of the equation remains the same as we differentiate with respect to B only. So the rest of these are treated as constants and therefore left alone, multiplying by the error in B. As for alpha, alpha is seen in the cos A and as well as cos A plus B plus beta, cos alpha plus beta. Sorry, alpha is seen on sine A, sine alpha plus beta. Treating the rest as constants. The differentiation of sine alpha is cos. Differentiating this using the product rule, we differentiate the outside equation multiplying by the reciprocal of the inside equation, which will be alpha be by 1. So you have cos alpha. So it'll be cos open brackets alpha plus beta, which we can see here, all on B2 sine beta, which has not changed as a constant. For the partial derivative of B beta, we use the quotient rule, as B is found in two equations, in the denominator and the numerator. So the equation for differentiating using the quotient rule is v du dx plus u dv dx on v squared, making this equation here RU and this equation here RV. The denominator would be v squared 2 sine beta all squared, as you can see down here, 2 sine, sorry, to be 2 sine beta all squared, and u v du dx, we replace v as 2 sine beta and differentiate with respect to beta using equation u, which would be found here. So just like how we found the equation of alpha, we will find it for beta. So sine differentiates the cos, and the reciprocal of beta, the derivative of beta is 1. So you get cos alpha plus beta minus u. So we put back the equation of u, which will be sine alpha plus beta, and differentiate the bottom, which we differentiate v, which will give us cos b. Plug in the values in to the equation. We have 2 by 100 sine 55 degrees, sine 55 degrees plus 25 degrees, all on 2 sine 25 degrees by the error in b, which is 0.010 plus 100 squared cos 55 degrees, cos 55 degrees plus 25 degrees on 2 sine 25 degrees by 15 on 206, 265. This converts the seconds to radians, as you cannot multiply a length by a distance by an angle. So we convert both equations. So we convert this equation to radians. Following suit, we now have 100 squared sine 55, 2 sine 25 degrees cos 55 degrees plus 25 degrees minus sine 55 degrees plus 25 degrees cos 25 degrees, all on 2 sine beta 25 degrees all squared by minus 25 on 206, 265, as it is once again. You cannot multiply a distance by an angle. This gives us a value of 1.909 for the first equation, plus a value of 0.86 for the second equation, plus the negative of this value. This value is a negative of 0.204, which gives us a difference of 3.02. There is some discrepancy between the first and second method. This could be due to one of my errors, but I'm not sure where we went wrong. So hopefully that is not a big issue. Thank you for attending the class, and I hope that the explanation was detailed and vivid, and see you guys again on next week, Wednesday, for accounts and economics.